Okay. Ahí va, una. ¿Eh? No, o sea, estoy grabando yo por mi cuenta. Vamos a poner las manos. ¿Quién va? ¿Quién va? ¿Quién va? ¿Quién va? Va. Sobre morro, a bañarse, a bañarse. Toalla, 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 al morro que se meta, que se meta, que se meta. Ahí va.
¿Por qué me pides permiso?
Silencio, please. Una. Lo tiraste en la cara. Oh, hi. Oh, hi. I'm going to talk about the curving variations in packaging process through Six Sigma way in large-scale food processing industry. Indian industries need overall operational excellence for sustainable profit and growth in the present age of global competitiveness. The paper is an effort to exemplify the application of Six Sigma quality improvement to one large-scale food processing sectors in India. The Indian company, well, Indian dairy industry is about 16% of the Indian food industry. India is the largest milk producer in the world, consists of nearly 20% of the world bovine population. This means that India has a huge potential that need to be developed in order to have a competitive advantage among other countries. The application of Six Sigma. Well, the methodology is having a statistical base focusing on removing causes of variations or defects in the product or core business processes. After globalization, quality became one of the major areas of concern. Six Sigma will be shown as an effective quality improvement to one of the large-scale food processing sectors in India. It is very important to know that Six Sigma is a huge tool to develop any type of industry. But what is Six Sigma? Well, Tom Kings in 1997 defined Six Sigma as a program aimed to near elimination of defects from every product, process, and transactions. It provides business leaders and executives with a strategy, methods, tools, and techniques to change the culture of organizations. The top elements of management, Six Sigma embodies the 5 elements of top-level management, which are commitment, training schemes, project team activities, measurement systems, stakeholder involvement. It is very important that every single person in the business know their role so they can have the commitment to fulfill their activities or tasks to reduce any type of defects and, like I mentioned before, to change the culture of the company. And the purpose of Six Sigma. Well, the main purpose is to reduce the deviation in the weight of milk powder packet of 1 kilogram category. Along with this prime objective, following secondary objective are also considered: introduction of the Six Sigma DMAIC methodology to the unit, making the unit familiar with the DMAIC problem solving technique so that the same can be applied on the other product line, creating the path for continuous improvement through Sigma level by reducing variations in packaging. And the mic needs to be done in a company. So the first step is a define phase. This phase helps define the problem in small details and also show in a more clear way the actions that are required to be taken. So for that, we need a problem statement that should be specific and measurable, since it is the base for the improvement efforts. In this case study, the problem statement was to reduce the variations in the weight of 1 kilogram milk powder pouch. Another tool to define it is a CTQ3, which is the critical to quality. This will help to recognize the critical quality requirements of the product. This will also help to identify opportunities through which a product may fail. Here we have a picture of the diagram about how the CTQ um, distribute the weight of milk powder pouch in kilograms. Then we have the measure phase, which is relevant data of current sigma level. The process of filling up 1 kilogram milk pouch was observed with a view to examine the deviation pattern. For calculation of baseline sigma level after a few trials, the data were collected for 25 samples, having a subgroup size of 36. This set of data were tested for normality and found to be satisfactory for further statistical analysis. Then, with that data, we analyzed through statistical control charts, X bar and S charts, the ones that we have seen in class, and CP and CPK values calculated through statistical analysis software. Well, here we have the X bar and S chart. Like I mentioned before, the ones that we have been working throughout the semester in this class. We have a capability histogram seen last semester also, the normal probability plot, everything, each value that was presented um, in the in the problem, here it is plotted. Then we jump to the analyze phase, which is we use several tools. In this case, this root cause analysis, also known as Ichikawa diagram, which is open after brainstorming for total 13 probable causes were generated for the problem of weight deviation of 1 kilogram of milk powder pouch. The main problems that we need to look for is the people, method, material, measurement, machine, and environment. Every single detail of it is affecting the deviation of the weight of 1 kilogram milk powder pouch. Another tool is the root cause analysis. Here, team members were asked to vote for each cause based on their understanding of the most probable or to least probable root cause for the problem at hand. The causes were voted by the team on a scale of 1 through 5, which 1 is the least and 5 is the most. Here we have the table. We have 12 probable causes of problems, and then the A, B, C, D, E, F, G are the voters. So they choose how probable it is that to happen. And after having an average, we know that wear and tear, stickiness of powder, feed rate, and changeover of product are the most probable defect that we can have in our process. Another tool is root cause analysis. Close to all root causes are shortlisted through the 5 why techniques. An example is that why wear and tear takes place between auger screw and tube. Then we jump to why powder sticks to screw material. Then why steel is used as screw material. Then why there is a play between auger screw and tube. Then why there is a considerable deviation in weight of pouch when machine is started. So by having the 5 W questions, we can reach to the root cause. And it is very important to know in what details we should ask. Here is an example of how it is moving towards the root cause. In this case, stickiness of powder. We jump to the surface roughness of screw. Then we know that the problem is the wear and tear of the screw surface. We can see that material of screw and then the chemical affinity with powder. We have to ask step by step to reach to the root cause. Then the improve phase. Well, this is setting improvement targets, presenting sigma level for filling process was worked out during a measure phase. The improvement phase need a design improvement measures. Alignment between auger screw and tube assembly should be checked more often. Air conditioning system must be able to meet the conditioning requirement. Calibration frequency of weighing machine should be at least twice per month. Design a feedback loop of control system. This um, this task should be able to be done in order to continue improving. And the last step is a control phase, which is depending on the type of the problem and operation system of concern. The following control measures were suggested. We have two ways to control everything, which is by a periodic review of the different measures in improved phase and application of statistical quality control charts like X bar and S chart to check the consistency of the process to maintain sigma level. This is very important because it shows us when our product is out of the limits, so we can continue improving our quality or maintaining our quality in order to be able to continue being a huge potential in the market. And well, that's it for me. And yeah.